Hello, welcome back. So let's kind of continue our review of vectors. Notes, we're talking about planes, cross products, and dot products. And we're going to review a little bit of pre-cal. In pre-cal, let's say we're given vector A as being AB and vector B being XY. Remember, these are what we call direction vectors. That gives me the direction that the vectors are heading in. And if we wanted to find the dot product of AB, we know that that dot product of AB would be AX plus BY. And we might recall that, right, because it would be AB dotted with XY. And of course, that would we just add their multiply their like components, A and the X's and the B and the Y's, and we add them together. If the dot product of the vectors are 0, then the vectors we say are orthogonal. Remember, that's just another word of saying perpendicular. Cross products of two vectors return a vector that is perpendicular to the other two vectors. Now you might recall this, that if the cross product, that from the cross product of two vectors, that's how we get the equation of a plane. So if you have one vector going, so if we take this vector and this vector, so we call this vector A, and this again, let's call this vector B. Their cross product would be a vector perpendicular to both of those two vectors right there. We can only calculate cross products to three-dimensional vectors. We don't do this with 2 dimensions. Okay? All right, so, and speaking of writing the equation of a plane, let's go ahead and review it. So we're given the following 2 points. We want to find two vectors on the plane, use those two vectors to find a vector perpendicular, and then set the cross products equal to 0 to create the equation of a plane. We've done a lot of planes in here, A, B, and C, so we'll call those points A, B, and C, and I'm just going to kind of label them A, B, and C. Remember, direction is very important, so I'll go from A to B, and I'm going to call this vector V, and I'm going to go from A to C, and I'm going to call that vector W. So I know vector V is AB, and I can easily calculate that by subtracting the like parts. 1 minus the negative 2, which is 3. 1 minus 3, which is negative 2, and then 5 minus 4, which is 1. I'm also going to look at vector W. Remember, direction is important, starting at A, going to C. Notice direction is important. I'm starting at the same place. That's really what you want to look for. Either you start at the same place or you end at the same place. So I can go A, B, A, C, or I can do B, A, and C, A. Those would be okay. We don't want to do A, B, and C, A. So that would be wrong, because then they're heading in the opposite direction. They're not heading in the same direction. Either away from each other or towards each other is what we want the vectors to do. So to get AC, we're going to subtract negative 3 minus the negative 2, which is negative 1, 5 minus 3, which is 2, and then 7 minus 4, which is 3. So we got our direction vectors. Now we're going to look at so we got the two vectors. Now we're going to find the vector perpendicular to those two vectors, which is our cross product. So now we're going to do V cross W. Remember, that's the determinant of that matrix, I, J, K, and then we use these vectors here, 3, negative 2, 1, negative 1, 2, 3. This direction doesn't matter. You can put vector V on top of W, or W on top of V. It really won't matter any. And then when we cross them, remember, holding the I's, we're going to get negative 3, negative 6 minus 2, so negative 8I. I'm just doing the math in my head. Remember, we're going to then we do the opposite sign, so we subtract for the J's. That becomes 9 minus a negative 1, so 9 plus 1. So that becomes 10. So we go minus 10J. And then for the K's, right, this becomes 6 minus 2, or 4K. So plus 4K. Remember, the only one, we changed the sign in the middle there. We had a video on that earlier. If you go take a look at that. And there is our vector here. Remember, we only really want to find the plane. So to find the plane, ready? Let's see what we remember how to do. To find the plane, we know that the dot product of the vector and the component has to be 0. So I need my direction vector here. So negative 8 negative 10, 4. Remember, this is going to be part of our equation of our plane. And I'm going to take this negative 8, negative 10, 4, and I'm going to dot that with the component form of the general vector. So I can go, and I'll pick the first point A, so it would be x plus 2, y minus 3, z minus 4. And that's going to equal 0. Now, we can use the dot product, and that's going to give us the equation of our plane right there. Or we can just use our formula. A, x minus x naught, plus b, y minus y naught, plus c, z minus z naught equals 0. And I would get A. This becomes, my A here is negative 8. X, I'll use my first point A, plus 2, plus B, which is negative 10, so minus 10, y minus 3, C, which is 4, and that's going to become Z minus 4 there. And that's going to equal 0. And there's the equation of our plane. Remember, this is the rule to find the equation of the plane. It's the dot product of the vector and the component. So we just pick basically any random point on there, and we measure the distance to A, or any point on that we know is on the plane. Okay. Next, to find the vector normal to the plane. Remember, normal is perpendicular. And recall, to get the equation of the plane, we use the formula. We use our little formula right up here, right? Where A, B, and C were the coefficients of the plane. But those coefficients were also the equation of the vector normal to that plane. So my A here is 3, my B here is negative 1, my C is 4. So to get the equation of our vector perpendicular to the plane, I can just look at those coefficients. So my vector is going to be 3, negative 1, 4. Or you can say 3i minus j plus 4k. Either one of them is fine. This is the vector normal to our plane. And the next question says, are the planes parallel or orthogonal? Well, to do parallel, there's a couple ways you can do it. I know there's a couple ways you can do it. I just like to check their directions. The first vector, the first plane, I can just look at its direction, 2, negative 1, 1. And then the second vector, 4, negative 1, negative 9. Notice, here I'm multiplying by 2. From 2 times 2 is 4. But here I'm multiplying by negative 9. So those aren't the same ratio. So these are not parallel, and that is because the ratios aren't the same. Now that's not the only way to do it, but it's a quick way. Aren't equal. To check perpendicular, remember this is our dot product. So take 2, negative 1, 1, dot that with 4, negative 1, negative 9, and I want to see what that equals. That's going to become 8 plus 1 minus 9, which is 0. Because it's 0, because the dot product is 0, therefore we can say these are orthogonal. Remember, that means perpendicular for us. Alright, well, I hope you guys enjoyed the quick review. We do have a short little assignment on this, so we'll talk about these later on. I hope you guys have fun today. Bye-bye.